Alright, I think I figured this out. So, I've been trying to port over this like demo effect that I learned from a guy who wrote an article back in 1999. So he was programming on DOS and had much different restrictions. Like I'm trying to port this over to OpenGL, so it's just a completely different way of doing things. And most of the stuff I've learned about demo programming has been from the old school OGs. So I sort of come at it from that perspective. We have to do things like pre-calculate functions in a giant lookup table, and then in your main loop, you index into that lookup table. But with OpenGL, you can do that with hardware rendering, you can do that in shaders, right? You can crank through and run a function per pixel, and it doesn't kill your frame rate. So I'm just figuring that shit out. So let's see if I can do this. So what I was trying to do is the old lookup table way, and then I'm like, obviously this is stupid. Let's just do the calculation in the fragment shader. So I'm gonna see if I can do that. So what I'm doing now is I have this big buffer texture that I'm passing to the fragment shader and indexing into it here with this texel fetch. I'm not going to do that anymore. We're just going to crank through the function here. So no more pre-calculating, no more texture. We don't need a lookup table anymore. We're going to get rid of that. Okay. So when we initialize, we're going to compile the shaders. We still need the vertex buffer and coordinate. Don't need the lookup table anymore. Keep the buffer width and height, we might use that. No more lookup table. So none of that. Alright, so let's run down to destroy. No longer need that. Wait, did I just... Yeah, okay. So, now we're back to basically just having two triangles, fill the screen, passing that to the vertex shader. And so now the fragment shader, I can get rid of the lookup table. Yeah, let's just do this. So this should give us a green screen if it still compiles. Yes, green screen. So what we do need though is the index of the pixel on the screen. So you can do that with, I forget, I have to look this up. OpenGL. Built-in variables. Frag chord. Wait, am I already getting that? Yeah, so I have that here. The 0.5 is because it calculates it the like half. The center of the pixel is at the half fragment width. Anyway. Okay. But what I do need to do is, okay, so before I was passing in the pre-calculated sine and cosine functions. I don't need that. What I do need is a color palette. So let's undo all that shit I did here, because we'll just reuse the... So where we have lookup, we're going to change that to palette. Lookup to palette. Right. So now we should have a texture for the palette, a buffer, and a uniform. We still don't need pre-calculate or create plasma texture. So uniform. So here's our uniform palette. Generate palette table data. Except it's not a lookup table, it's just, well, I guess it is, but anyway, palette data. So we're going to have 256 colors, right? But, so I've tried passing a buffer of ints to the shader before and like stuffing the bytes for each color channel into an integer. So you have like 8 bits, you have a byte, right, for the red, 8 bits for green, 8 bits for blue, and 8 bits for alpha. But I can never get it to work, and it's because of the way, just telling OpenGL how to use this integer, I can't figure it out. So for now, I'm just going to go times 3, right? So I'll store an unsigned car, basically, right? 8-bit integer for each color channel, red, green, and blue. Like back to back, and then when I index into the buffer, I'll just have to calculate an offset by like times 3 plus either 0, 1, or 2. So you'll see that in a second. But so yeah, it's 256 times 3 is going to be our size. So here's the data. It's that big. So I'm just going to set it to 0 to start with. And then so it's going to change over time. So in our main loop, we'll update it every render call. So we generate a buffer, bind it to this target, fill it with this data, and then that's just unbinding it. Then here we create the buffer texture for it, and fill it with this buffer. Great. So here what we need to do is change the data. So I'm just going to loop through, let's get, so we're going to change the red, green, and blue values. So for I equals 0, so there's 256 colors. We're going to set each in this loop, right? So red is going to be some sine function. I actually have these, because like I said, I'm porting this over from one I wrote that just calculates this all in software and then just does a render call. It's called Plasma Oldschool. Right, here's where I'm creating the color palette. Damn it. I don't open this. Palette. Here. Okay, so I don't know why I did these in 2 lines. Okay. Except it's not int, it's an array of GL unsigned bytes. Right, so cosine of the index times pi. Do I have pi? No, let's define pi. 3.14159 something. Okay, we'll just use this. Put it, yeah, that's fine. Okay, we have pi now. So every frame we update red, green, and blue in our palette. Okay. Now we need to update the texture with this data, so active texture, bind it, text buffer, but we need to update the buffer, so what's the call to do that? GL buffer data. Okay, I think I need to bind the buffer first. GL bind buffer. That's the texture buffer. Texture buffer. Okay, so bind the buffer, fill it with this data. I don't have buff size anymore, so 256 times 3. It's not static draw, it's dynamic because it's changing every render call. Okay. Bind the buffer, fill it with this data, activate the texture, bind it, correlate it with DCF buffer. Okay. Then this is how I'm passing it to the fragment shader. I think we're all good. So now I have my uniform sampler buffer called palette. Okay, so now I need to say texel fetch from the palette. This index. But first I need to do some more shit. Well, let me see, is there a simple way I can just test this palette? Yeah, it's filled with a bunch of shit, so what should we color? Let's just grab like 69. And say, so this returns a float. So I pass in unsigned bytes, which is a value between 0 and 255. There's a name for that. I think OpenGL calls it like normalized integers, which is, I don't like it, but like the normalized part is fine, but anyway, what it does is it takes that 0 to 255 integer, maps it to a float between 0 and 1. So float color is this thing, and then we'll just say put that in the green channel. So she gets some green shade of green here, if it's working. So does it compile? No. Current time doesn't exist because I call it something different. This is where I'm getting it, but I'm going to do that up here. So float current time equals glfw get time, and then here I can use current time, and there I have it as well. And their palette is called palette data palette. Oh, make. Oh shit. Do we have anything? No. Undeclared identifier green. That's dumb. I'm an idiot. Oh, I didn't need to recompile. So, incompatible types. Right, because I need to pull out. So, I told it I'm only going to use the red channel for this. Right. Here, somewhere. Basically right here, right? I said I'm only going to use 8 bits, the red channel. And then down here when I use it, I feel like I'm missing something. No, that's for regular textures. Yeah, for a buffer texture, this is all you're doing. Because it's always 1D, right? I think it's always 1D. But anyway, so I just need to pull out this red channel. Yes. Yes. Fuck yeah. So it's changing over time because that's what I told it to do, right? Here. I'm updating the palette every frame by, you know, some sign value of current time. Beautiful. Okay. Shit. Okay, I'm gonna go get a power cord. Okay. Song's kind of hot. Okay, so I have passed the palette and I need to index into it now. So the way I'm doing this is basically I'm going to get the distance of each pixel from the center of the screen. And take the sign of that value to get like a circle basically. So let me just I have these calculations, they're just done differently in the old version. Yeah, so here, for example, in the lookup table, I'm saying This one's the circle right here. This is hypotenuse. Like this is a leg of a triangle. This is a leg of a triangle. Getting the distance between them, the sine of that, and then just mapping. Since sine goes from 0 to 1, I'm mapping it from basically 0 to 255, right? Because I take 128, shift it up, so that would be negative 128 to 128, shift it up to 0 to 255. Great, so I just want this basically. Oops. Or something like this. What is this? So there's no hypot function in GLSL, but they got, I think they have a, I basically need the distance between 2 points. Math functions. Not on GitHub. I want the actual. No, not the spec. Just want to know what functions I have. Like built-in functions. Built-in functions. Like, see, I have sine, but what else do I have? There's a reference for these functions available here. Yes, okay. So maybe it does have hypotenuse. G. Oh, that's U. G. H. Hint, no. Distance. Distance. Distance between 2 points. Turns a float. This is what I want. Okay, so turns a float, we'll call it, it's the distance from the center of the circle to the pixel, basically. So we'll call it center dist. Should call it dist center. It's distance between 2 points. This point and this point. So the center of the circle is going to be at buffer width, half of that, and y half buffer height. And the pixel is xy. Okay, so that's this right here. So what I want is an index. So this was giving me an index into the buffer, but what I want is an index into the palette, which is what this was, right? Because, yeah, actually the values in the lookup table were themselves indices into the palette. So this is going to be the plasma 1 value. So I want a integer. It's going to be an endcast of times sine of center dist times this value. Right, so this is going to give me a value between 0 and 255. For each pixel, right? Because it depends on X and Y. So this should give me a circle if I were to map this right now. Okay, but it's an integer between 0 and 255, so if I say float is a float cast of plasma 1 divided by 255, that should give me something I can use. It should give me like a crazy looking circle. Yes, that's exactly what I want. Type. Okay. So this working. Well, so now since I have a value between 0 and 255, I can index into this texture. I want value plasma 1, right? Wait, right, so I stored each color channel as a separate element in the array, so I need to pull those each out. So this is not color, this would be like R. This is a good jam, I like this track. This is Ben Bomer, I saw him live. Plasma 1, so that's the index. So since you have them stored 3 in a row, right? You have red, green, then blue, then another red, green, blue, then another red, green, blue. What you need to do is multiply this by 3 and add the offset, which is 0 for red, so nothing. And then for G and B, it's the same. G, oops, B. R, G, what the fuck? What the fuck is going on? G, B, B. Okay, but this is plus 1, and this is plus 2, right? So this will give me color RGB. No, but it's these are always R because with this texture I'm only storing it in the red channel, right? This just pulls out the byte. So this says like get a byte, get a byte, get a byte. I don't know. So all of those I can throw in each of these channels, right? So R, G, B. And hopefully we'll now get a crazy circle with weird colors. I don't need to compile because I only changed the shader. No, something's fucked up. Something's fucked up. Let me look back at this, make sure my colors are right. Right, so I'm getting this color. I'm not going to change them over time yet. The center disk is working. It's giving me a value between or actually 1 and 255, but since the palette wraps like 255 is the same as 0, so there's that. This is a value between 0 and 255. What is going on? I don't know what's wrong. I should be seeing color. But I'm only getting this weird ghostly black and white. This shouldn't matter that it's going between 0 and 255, because that's the size of my texture. I mean, I can check by so my color value is going to be, sorry, it's still because it's still an index. What if we just do mod? So mod returns a float ridiculously. Mod plasma on 255. That really shouldn't matter. And it does, to be expected. RGB. What is wrong with you? Something wrong here? Oh, right. See, this is the version that I was trying to pack each channel into an integer, right? But this is gigabytes, so, or this is, yeah, I'm not using integers. So what I need to do is just directly put in the red, green, and blue. And that's why it was gray, since for an integer, like every value is going to be the same for these. So these were getting the same value, which is why it's like grayscale. So that should work, right? You're going to set RG to B, go 0 to 56. That makes more sense. Let's try that. Yes, that was our goal. Okay, now we are making progress. Okay, so what I want to do now is translate this over time. So we're taking in elapsed time. There's the only thing in here that's camel case, which is fucking stupid. I'm gonna do that. And change every instance of elapsed time to elapsed time. And hopefully I didn't just break it. So what we were doing is every render call, you get a new index into the vertex or into the lookup table. I'm not going to do that anymore. I'm just going to translate by an offset, right? So what I need is an offset X and Y. And what are those going to be? Well, some kind of sine and cosine function. So x1 is going to be this guy. Gross. Ugh. What the fuck is going on? Okay. It's just a cosine function of elapsed time. I did divided by 9.7. I'm gonna multiply because it's cheaper. What is 1 over 9.7? This value. So before this pre-calculated lookup table, it was twice the width and height of the window, so that you could translate the function over the window. So what I want to do is have my offset just be like half the window to the left, half to the right, half up and half down. So cosine will give you a value between 0 or -1 and 1. I want to go from negative half the screen to positive half the screen. Yeah, so half of buffer width times that. Makes sense. Then the same for offset y, except for it's going to be half the height. And I'm going to use a different function. I like the values here, so I'll just reuse those. y1 was sine divided by 12.3. So sine divided by 12.3. Okay. So now when I calculate the center distance, instead of using x and y, you're going to use x plus off x and y plus off y. I'm just going to move this guy down here. Okay, so now the circle should just like translate all over the screen. Except I fucked some shit up. No incompatible types, line 17. Oh, because this is a float. So we just round it to the next pixel. And it's moving around the screen. Wait. And changing color. This chair's not comfortable right now. Okay. Okay, so now we just need more sine functions. Let's throw in one more that is like a... So this one is using like the sine of the distance from the center of the window, which is gives you the circle. We're just gonna do sine of x position, so you get vertical lines of different colors. Yeah, so your plasma 2 value is going to be an incast, also going from 0 to 255 of the sine of, we're just going to have x, but plus an offset. So we're going to do x1 and 2. X plus off x times some value that will give us kind of the period of the sine wave. So let's go like every 16 pixels. That's 1/16. I know that because I've used it recently. That makes sense. So if we just test just this value, this should be giving us vertical lines that move because we already have our offset. Or no, I forgot to define the offset. So off x2 is going to be the same thing, but I have a nice one here. We're just going to do sine of current time divided by 13.7. So also sine. So what is 1 divided by 13.7? This thing. Okay. So this should give us vertical lines. Yeah. So if we just combine the two, we get plasma. So you want mod of plasma 1 plus plasma 2 mod 255, right? Because each of these goes between 0 and 255. So they're going to add and wrap, which is why we have a palette that wraps around itself. And this should give us fucking plasma. Boom. It bugs me that it slows to a stop like this. But it's because we have sine functions of different periods, right? And these periods initially are out of sync, so like the circle is moving x and y, and then the vertical lines are moving x, so it's really only the x's that matter, right? The period of the sine functions that deal with x. But at a certain point, those two sine functions become in sync, so they're like the same. That's why this happens. Looks fucking rad. Ugh, now it's really synced up. So I think the only, really the only way to fix that would be to give them the same period and keep them offset. Right, like from alpha. So if we plot y equals sine of x times some arbitrary value, what was I using, like 0.666? We get some function. And if we take another one, can you do 2? Sine x times 4 or something, right? These should eventually oh, let's do something close. right? Like, so they're out of sync, and they start to go in sync at some points, right? And since our time's moving actually kind of slow, like at the points that they're in sync is when the plasma seems to be like not moving at all, and I don't think it looks good. So the way to change that is if you had like the same period. So like 0.666, you should always be out of phase just by well, the difference in sine and cosine is what? Pi over 2. If you really wanted, you could do like plus pi over 2. Must be pi. Yeah. Now they're completely okay. So, but basically they have to have the same period. So if I were to change this one to the 10309, I feel like it's gonna be too fast now though. Seems that my theory may be wrong, because it's still slow as shit. Right there, anyway. I mean, I do still have the Y offset changing by a different period. I could sync that one up as well. But I mean, there's always going to be a point where they are in sync. Or maybe I'm thinking of it wrong. Maybe it's not when they're in sync, it's when they're perfectly opposite of each other, so it's like destructive interference type of thing. Still looks tight. Definitely changed something though. Let's try that. Let's give them all the exact same. Well, no, you don't want the same. Let's just try it with the Y. Or honestly, you know what it? I know what it is. I feel like it's just because the values are changing relatively slowly, right? And it's a sine function, so it has to change direction. So like when it's going this way, and when it goes to change direction, it seems to stop for a while because it's moving so slow, right? Because these should be shifting, I feel like, and they're not. We're getting a lot of those. I'm gonna check the frame rate. I think I like the old shit better. Ooh. No, it stops. So, where's our main loop? I think I have something. Yeah. So this should give us frame rate. Alright, so we're hitting 60 frames a second easily. I want this to shift faster. Colors anyway. Look, we could just add another offset, like just a constant. Like some stupid value, 69. I mean, all that's going to do is shift that color. What I want is like these colors to change faster, like the morph one. Yeah, I just need to speed up the. I don't need that. So how's my palette changing colors? You can get rid of this division as well. Let's just do like much faster. Like 5, 4, 3. Yeah, see they're changing a little faster now. Although, what if we just do like straight up current time? See what's happening with it. Well, it's better if they're out of sync, but let's see if its speed is okay. Yeah, much better, see? Looks way cooler. Now we just need to shift them like at different intervals, I think will look good. So we'll do this one times 1.1. Times 0.9. Sweet. Okay. Hopefully that's not super fucking loud. It's not too loud. So I know it's watching this shit anyway. Alright, I'm gonna take a break because we did some cool shit.